Today, we're going to be continuing our conversation about probability. So, we're going to be looking at mutually exclusive and independent events today. So, we're going to be starting with mutually exclusive events. And we can say that two events, A and B, from the same sample space are mutually exclusive when A and B have no outcomes in common. Meaning, like if you were to roll two dice, the event A of rolling a total of 6 and a separate event B of rolling a total of 9 are mutually exclusive. So when we have this mutually exclusive event, we can actually use, and you'll notice this symbol here, you can use something that's called a union. So the probability of the union of A and B is actually going to be equal to the probability of whatever we calculate for event A plus the probability of whatever we calculate for event B. So let's look at an example of what this looks like. So the Human Resources Department of a company has compiled data on the numbers of employees who have been with the company for various periods of time. The results are shown in the table. So you can see that there's a bunch of different years of service here and the number of employees that fit in that category. So we're saying that an employee is chosen at random. We want to know the probability that the employee has 4 or fewer years of service. So the first thing that we need to kind of figure out is, well, what is our total sample space? So if I were to go ahead and add up all of these numbers, the 157, 89, 74, et cetera, we would have a total number of employees of 529, which is representing our entire sample space. So the probability that from this list, we were to choose an employee with 4 or fewer years of service is pretty simple. So I'm going to say the probability of, we'll say that this is event A, is going to be equal to the number of 0 to 4 year employees over our total. And the number of 0 to 4 year employees is 157 over our total sample space of 529. So that's going to tell us our probability that an employee has 4 or fewer years of service would be about 0.297. Okay, but what if we want to calculate the probability that the employee has 9 or fewer years of service? So the last one was pretty straightforward because the 0 to 4 years of service was pretty much the first category in our table. But now we need to take into account both of these things. So we need to take into account the 5 to 9 years of service and the 0 to 4 years of service. So I'm going to call this event B. So I'll say that this is the probability of B happening. But the first thing I need to know is, well, what is the probability that I'm just going to get an employee from the 5 to 9? So we'll do that first. So number of 5 to 9 year employees over the total, which is 89 over 529. And I know I calculated a decimal in the last one, but I'm just going to leave this one as it is right now because we're not done with this problem yet. I don't want to know the probability of picking a 5 to 9 year employee. I want to know the probability of picking 9 or fewer. So this is where the mutually exclusive formula comes in. I'm going to actually add the probability of event A to the probability of event B because the event from A and B have no outcomes in common, meaning that these two categories are completely separate. So I'm going to say the probability of the union of event A and B is going to be the probability, of event A plus the probability of event B. I've already got both of those calculated. I'm going to use the fractions that I have here. So 157 over 529 plus the 89 over 529 to make a total of 246 over 529, which is about 0.465. So the probability of selecting an employee that has 9 or fewer years of service would be about 0.465. All right, so let's move on to independent events. So independent events are a little bit different. Two events are independent when the occurrence of one has no effect on the occurrence of the other. So for example, if I were to roll a pair of die or just a die, I could roll a total of 12 with 2 6-sided dice, and whatever I roll in that first roll has literally no effect on what I roll in my next roll. So that's what an independent event is. So when we talk about independent events in terms of probability, we can say that if A and B are independent events, that the probability of both A and B will occur is given by a different formula. So the probability of A and B occurring is the probability of A times the probability of B. So look at a couple of examples of what this looks like. So example 2 is telling us a random number generator on a computer selects 3 integers from 1 to 20. We want to know what is the probability that all 3 numbers that are selected are less than or equal to 5. So the numbers that are less than or equal to 5 in this set of numbers that were given could be 1, 2, 3, 4, or 5. So my probability of selecting some number from 1 to 5 is 5 numbers out of 20, which I can simplify to be 1/4. So that's just the probability of selecting one number from 1 to 5. But it's asking us to calculate the probability that all 3 numbers are less than or equal to 5. So this is going to be where my independent probability formula comes in. So basically, this is telling me that the probability that all 3 numbers are less than or equal to 5 is actually going to be the probability of this event multiplied together 3 times, because every single time I would have a probability of selecting 1, 2, 3, 4, or 5, so a probability of 1/4. So my probability is going to be 1/4 times 1/4 times 1/4, which gives me a probability of 1/64. And you can get a decimal for that, but I'm just going to leave it as an exact fraction. Something that's a little bit different is example 3. So in 2009, approximately 13% of the adult population of the United States got most of their news from the internet. In a survey, 10 people were chosen at random from the adult population. We want to know, what is the probability that all 10 got most of their news from the internet? So the probability of an adult who gets their news from the internet is 0.13. And that's coming from that 13%. So it's telling us that in a survey, 10 people were chosen at random from this population. So choosing another adult that got their most of their news from the internet would be 0.3, and then choosing another adult after that who got their news from the internet would be 0.13, and so on. So since these events are independent, basically what that's telling me is that the probability for all 10 of these people chosen at random would be the probability, let's call this event A, of event A multiplied out 10 times, since we're talking about 10 participants in this survey. So that's 1, 2, 3, 4, 5, 6, there's 7, there's 8, there's 9, and there's 10. But a simpler way to write this, rather than writing this out 10 times, is really saying that this is really P of A raised to the 10th power, because there are 10 of these numbers being multiplied together. So when I calculate my probability, that's a lot easier than writing 0.13 multiplied out 10 times. So this is the same thing as putting in our probability of this event, so 0.13 raised to the 10th power, which is going to be a very, very small number. I believe you get 0.2, 3, 4, 5, 6, 7, 8. You have like 8 zeros, and then 1, 3, 7, 8, 5, 8. So the probability that 10 people were chosen at random that got their most of their news from the internet would be about this. So let us know if you have any questions on anything, and good luck on your homework.